Hey pre-calculus, so in this video I'm going to be talking about section 4.7 day 2, and we're going to talk about the ambiguous case. So the ambiguous case has to do with the law of signs. And the ambiguous case is for the triangle that you used to not be able to talk about because it's not school appropriate. We're going to say side-side angle, right? So side-side angle triangle, and if you remember from geometry, you can't have side-side angle similarity because there could be two different triangles. So the whole issue is because, I'll draw a little picture. Say this is your triangle, and this is angle A. Wherever this would be B. This is going to be C, so this is side B. Side C is over here somewhere, and this is side A. And I'm just not going to care about side C for my example. So the issue with the side-side angle triangle, when you have side, side, and an angle, is you don't know where like the height is. This could be two different lengths and connect to that third side. So what you need to do, step 1 with the side-side angle triangle, is determine the height. So the height is going to come down at a right angle, right? And the height can be found by using right triangle trig. So it's going to be side B times the sine of angle A. Okay, so that will give us the side length. And then once we have the height, we can figure out how many triangles there are going to be. So step 2, we're going to use rules. There's to determine the number of triangles based on A, B, and C. So here's a cool little visual of a side-side angle triangle for the ambiguous case. So like I said, we're giving an angle and we have two sides. We need to figure out the height because depending on this length, right, there could be no triangle. Let's increase. There could be one triangle, or there could be two triangles. So we need to figure out, is there two different triangles, right? Triangle 1, triangle 2, or 1 or 0. So here are the rules. How many triangles? So if this length is less than the height, as you can imagine, if it's smaller than the height, then there's not going to be any. There's 0 triangles. If that side is equal to the height, then there's going to be one right triangle. Because it'd be going straight down here. If the height is smaller than A, right? So that means A is long enough to make a triangle, but it's A is smaller than B, then there's going to be two triangles. And this is when you're going to have to use the steps to solve for an ambiguous case, which we'll talk about in a couple minutes. And then the last thing is if A is bigger than B, there's one triangle and no height is needed. So if A is just bigger than B, there's just one triangle. You don't need a height because you'll be able to solve it. So you just don't even have to worry. Alright, so those are the rules that you need to know. So let's just do a quick practice problem of just determine the number of triangles. So determine the number of triangles. We'll say if angle A is equal to 42 degrees, side C is equal to 15, and A is equal to 12. Whatever the units are, I don't care. So first thing you need to do is draw a picture. I like to draw my picture the same way every single time. I don't know why, but the consistency, like being consistent about how I draw the picture just always really helps me. And I'm a very visual person, as you guys have been kind of learning. So, I'm going to draw my picture. And this is going to be the angle I'm given, and it's a 42-degree angle. And because I know side, like the side across from it is 12, and the side over here is 15. Okay, and then we need to figure out our height. Right? So, I'm just going to plug it into the formula. So remember, height is equal to B sine of A. But in this case, or you could just think sine is equal to opposite over hypotenuse. That also is going to work. So our height is going to equal 15 times sine of A. And I guess I could even, for this example, it isn't B, it's technically C. Okay, so that's the exact answer, and then I'm going to use my calculator. So the height is approximately 10.3, oh just kidding, 10.03. Okay, so now I need to compare the height to the short side, right? We don't know exactly, like, is that going to work or not, so we have to compare it to the height. So if the height is 10.037, that is less than that side. It's less than 12, and 12 is less than 15, right? So the height is less than A, which is less than B, so that means you can use this symbol, which means therefore. So therefore, there are going to be two triangles. Okay, so if I want to solve for the triangle, I'm going to have to solve for two triangles. There's going to be the potential ABC and then another ABC over here. So let's just talk about the steps. How would you solve for a right, or not a right triangle, but a triangle that has essentially two potential triangles? So steps to solving. That has two options. So the first thing you need to do is you need to find the height. And you need to show that you've determined you need to do this. You need to determine how many triangles. And if you've determined that there's two potential triangles, now you need to solve for them. So the first thing you want to do, or I guess technically now we're on the third step, but once you've determined, okay, there's two triangles, you want to use the law of sines for your angle C. So let's draw a picture that we can use for reference. Where did my ruler go? There it is. Right, so there could be a C right here if there's two triangles, or there could be like a C, I don't know, somewhere over here. We'll call it C prime, right? Because the whole concept is this side is actually so long, like it could either intersect here or over here. Remember that visual I showed you earlier. So we're going to use the law of sines and we're going to solve for C because we're going to be given angle A. We're going to be given this side and this side. So we're going to solve for angle C first using the law of sines. We're going to use the triangle sum for the third angle. Okay. And then we're going to solve for your third side. Sorry, and when I say third angle, I mean like this angle B, right? So we're going to solve for this angle C, and this would be the equivalent B, so we're going to solve for third angle, which in this case is B. Then we're going to solve for a third side. Which is going to be this side, because we know. Okay. And then we're going to have one triangle. So that means we're going to have angle C, side B, angle B. So solve for all that. So then the sixth thing you want to do now is kind of the same thing and solve for your second triangle. I know all this kind of seems confusing. I'll do an example using all of the steps. We'll do that in class.